Well, good afternoon. My name is Krista, and I'm a professor at the University of California in Irvine. I'm also a developer in an open source project. I've been doing that since I got tenure because I was so eager to go back to actually writing code that I had to find something to actually get my hands dirty and get that feel again for what it is to actually develop systems. And I'm going to talk to you about programming styles today. And this talk is very much a talk for people who enjoy programming, who actually think that it's a really, really cool thing to do as an intellectual activity. So, programming style, let me just tell you why I'm going to talk about this and why I think it's important. I don't know about you, but in this large project that I'm a developer, there's lots of other people committing code to it. And sometimes, actually, when I see a piece of code, I can tell who was the people who wrote it, right? You just can tell. There's some elements in there that you start, as you start knowing more your coworkers, you start detecting these patterns of writing code that are very familiar to and very specific to this person or another. And when you go in and actually patch some bug, it's important, I think, that you give an immediate feeling for what was the style that was applied there. And either two things can happen: either you really don't like the style, and you better be ready to refactor really intensively, or you just, put your the likes and dislikes aside and just try to match the style that was there in the first place and fix the bug. Otherwise, if you start mixing your own style with the style of the person who wrote the code, it's going to be a big mess. Now, in style, if you work in a company, some companies sometimes also have rules for how to produce the code, the styles that you apply, and that's all good. Open source is a little bit more, in some projects, a little bit more flexible about people being able to express themselves in the way that they think it's best reflects what they are thinking. So what is this idea of style? Well, programming styles in general are things that exist everywhere. This is not new to programming, right? We've had the notion of style forever, in the arts particularly. So I could talk about the literary arts, but this is painting, about the fine arts, and you see these different styles. What are these styles? Well, you have modernism, impressionism, realism, and what these things really are, when you go to art school and learn about these different ways of expressing yourself through painting, are really just constraints about how to express your ideas. So if you want to produce a painting in impressionist style, well, you better avoid very sharp lines, for example. The forms are emerging from a bunch of little dots that you apply, etc. If you want to express yourself in modernism, so you better, relinquish the idea that you're going to depict reality, right? You don't depict reality, you depict some abstraction of reality. Those are constraints. And those constraints can be learned. They are techniques, they are ways of thinking, and you can learn them. People do a very good job at teaching in the art school how to produce works in specific styles. We don't do a very good job in computer science in doing that. So, if you go to art school and if you really don't want to get very sophisticated, you end up with like an art history simplified and all the different ways of drawing faces, right? And styles in the fine arts are very often associated with specific artists, right? You have the Dali style, the Picasso style, and those are all things that you can actually try to imitate if you want. So what are programming styles? In programming styles are just the rules and the constraints that you want to apply when expressing what you want to do. So is this thing jumping on me? Stop. So they are ways of expressing tasks. The other interesting thing about programming styles is that they exist in many scales. So they exist at the small scale of program writing, right? And they also exist at systems level. When you design entire systems made up of components, you also have styles, ways of thinking about how to decompose the problem and how the components interact. And what I find interesting is that some of those patterns, some of those styles that you apply at the micro level, many of them actually also apply at the systems level design. Okay, and so it's not by accident that a lot of people who are very good in programming languages and people who write compilers and design programming languages also often end up being very good at writing systems. It's because you just have that conceptual model about how the little pieces interact together and have sort of some flexibility about thinking. So these patterns, these styles, they exist in many levels. And of course, we all know that they are, in a way, frozen in programming languages. Certain programming languages are enforcers of styles, right? Some people thought, well, I think that the right way to express yourself is to think about objects, okay? So now let me design a language that is forcing you to think about objects. Or I think that the best way to express yourself is in terms of functions. So now let me design a language that forces you to think in terms of functions. So programming languages freeze some of these programming styles, okay, for a reason or another. So why are these important? Well, each one is important on its own self, but I think what's more important here is that the realization that there are many programming styles, not just one, okay, and this is one thing that I'm a professor, so I teach students, and one thing that we don't do very well is that we teach people 1 or 2 styles at most when they come out of university. And people get the wrong idea that that's how they should think about software. In fact, that's not true. There's lots of different ways of thinking about software. But they also serve as common vocabularies for talk about within teams, right? They are frames of reference over which you actually write the code. And we all know that some styles are better than others. We all have this idea, but it depends, right? It depends on a lot of things. It depends on what you're trying to optimize. And many times you're not trying to optimize the same things in different circumstances. So it's really important when you have those wars in teams about what's the right way of doing things. It's really important to understand what is it that you're trying to optimize. Maybe you're trying to optimize, the number of lines of code, or maybe you're trying to optimize, the ability for other people to understand other people's code, or maybe you're trying to optimize, the speed. Or there's lots of things that you may want to try to optimize, and depending on what you want to do, then you pick up the right programming style that can help you achieve that goal, or can hamper you to achieve that goal. So there's not just one. There's not one that's always best. It depends. All right, so, being in academia and being a professor of computer science, I often found myself, I actually taught the programming languages course introductory, and I just shook my head like, they are not learning what they should be learning. I mean, we teach them programming languages, but there's so much more to developing software than this, really. There's all these different ways of thinking about the problem. And it's these ways of thinking about the problem that I think it's really important to teach. So now we know this, and in fact, we have the same problem in some other courses, not just programming languages, but we also teach courses on software architecture, for example. And software architecture is the same problem, like how do you teach software architecture? And the problem there, it's even worse, because software architecture only makes sense when you actually have a large system full of, different components interacting with each other. So the students many times aren't prepared to actually assimilate those teachings because there's just too much complexity at the time that they can handle. So it's important to be able to teach these things. So in order for me to kind of wrap my head about to teach it, last year or so, I ran across this author, this French author. And again, if you want to find interesting, crazy ideas, it's always good to take a look at the French intellectuals of the 20th century, because they are really interesting. Anyway, so this guy, Raymond Queneau, he started this club, a workshop of potential literature, if I can translate it to English, OLIPO. It's basically a club of French intellectuals, writers, and mathematicians. And their whole motto was constraints. So their whole idea was that you would give them a constraint, and they would produce a work based on that constraint. And a piece of art, a literary text, you name it. And so these were constraints, any kinds of constraints, either constraints about, mathematical constraints, abstract constraints, or you cannot use that word, or things like that, okay? There's a book, let me make it on the side, there's a book that I recommend from a person who was part of this club. I forget the name because I cannot remember names, but he wrote this book called, in English, Avoid. Has anybody here read Avoid? No? Yeah? A couple of people. Anyway, so what's interesting about that book is that the book is really interesting. It's an interesting story. And it's not small. It's actually quite a medium-sized book. It's very engaging. And so, besides the story, what's interesting about the book is that the entire book is written without the occurrence of the letter E. Now, try to write something without the letter E. Right? That gives you immediately something, a very strange style right there, because some words that you think might be the natural words to flow, you cannot use them because they have a letter E. So you start using obscure words because you have to apply this constraint. Anyway, so this is an interesting book, look it up. But besides that one, so Queneau himself wrote an interesting book called Exercises in Style, which consists of the following thing. He took up a little story that's a completely dumb story, can be told in 30 seconds. And he wrote this book with 99 different ways of telling this story. Okay, it's just obsessive, compulsive all the way through. Okay, just one way, another way, goes all the way. So here's some of his styles: metaphor, surprises, dream, prognostication, hesitation, precision. Lots of different styles. And these are the names, by the way. I'm not even sure that he gave them names. I think the translator gave these styles names to kind of... So the association between the name and the actual rendition is relatively fuzzy, and I'll talk more about names in a second. Anyway, so when I found this book, I said, wow, this is it. Okay, if I wanted to learn how to write literary words, I really want to read this book, because it will teach me it will make me aware of how the different constraints that I can apply to actually help me write, right? Constraints are good. They help us create. When we don't have constraints, it's really hard to create things. So I thought I'm just going to steal this. This is the best idea ever, okay? So I'm going to get a program, I'm going to write it in obsessive compulsive mode, as many ways that I can possibly write the program. So that's what I'm doing. So I am, here's the story of my program, term frequency. Everybody here can do term frequency, okay? Take a file, count the words, normalize them to lowercase, eliminate the non-alphanumeric, remove the stop words. If you don't know what stop words are those words that exist in languages that are so frequent that they don't have any signal. So things like the in English. So remove the stop words and then count the words and present them in decreasing order of frequency. I'm just saying the 25 most frequent words. Okay, so that's my program. Everybody can write this. Every student in the junior year can write this. So if you get, for example, Pride and Prejudice, one of my favorite books, you would get a list something like that. Okay? Here's the input, that's the output over there of this program. So how many ways are there to write term frequency? Think a little bit. What would be your first approach to write term frequency? Okay, there are many ways. If I would give, all of you this exercise, I'm pretty sure I would see at least 50 different ways of writing this. So before I go on, so this is what I have been doing on and off. I now have a collection of them in GitHub. You can look them up. My goal is to reach 33, and then I stop and I write the book to explain what's going on. But 33 is not, it can go much higher than 33. So let me go here for the rest of the talk, and I will just go through some of these styles, okay? Now, I'm going to need your help, okay? So here's what happened. About a month ago, I came here to Aarhus to a meeting of a small club like the Olipo Club, experts in programming languages, and I sort of present them some of these ideas and the styles. And I did something really stupid, okay? And they killed me for it. Here's what I did. I decided to give technical names to these styles, okay? And as soon as I started using technical names like functional style or imperative style, they just killed me. Because they just went into a war of names, right? Oh, no, this is not functional. You're forgetting blah, blah, blah. Oh, no, this is not imperative. Okay, oh, my God, okay. So in order to completely avoid the problem altogether, I just took a step back and said, okay, I'm not going to name these things, okay? You know what? I don't care about the name. What matters here is the constraints, okay? You have to write the term frequency using this set of constraints. Now, whatever you call it, it's up to you. In fact, this is where I need your help. Help me name these things, okay? I'm going to present you the constraints, and you help me name the things. And the way that if you want to participate, tweet me. Hashtag, that's my tweet name, hashtag style1, and tell me what the name of that style should be, okay? Now, I should warn you that the numbers here do not correspond to the numbers that I have in GitHub. I just have 1, 2, 3, 4, 5 here on the talk, but are not the same names that I have on the GitHub repo. Okay, so here we go. Style number 1. Don't try to read. This is just to tell you that this is a page of code, okay? Now I'm going to zoom in, but even before I zoom in, you can already see there's a lot of indentation here going on, right? So there's a lot of nested scopes. So I'm going to zoom in on different parts of this example program so that you have an idea of how this program is actually written. Okay, so it starts by having a global variable. So word frequencies, this is going to hold on the word frequencies over here. And then I just open the stop words and I just load them all up so that I have the stop words already ready to go when I need to compare them, okay? And then basically what I'm doing here is 2 nested loops. One that iterates over the lines of the file, and one that iterates over the character in each line. And you can see the story, right? So you iterate over a line, you iterate over a character, you try to detect the beginning of a word, the end of the word, try to normalize as you go. When you detect a word, see if it's a stop word, you ignore it. Okay, so that's all the logic that's going there in those nested lexical scopes over there, right? So that's one way of doing this. So what are the characteristics of this style? What are the constraints? If you want to write a program in this style, what are these constraints? Let me tell you what they are. No abstractions, okay? You don't define procedures or functions or objects or anything. You just start in line 1 and end in line n. Another thing that you also don't do is use libraries. Basically, don't use libraries. Do it all yourself, okay? So I need a name for this style. So I'm just going to give you my own name. Actually, I think I have many names for this. Monolith might be a name. Another name might be brain dump. This is kind of a style that you end up with when you're really in a hurry to do something and you don't even want to think about how to, what kinds of abstractions or what library functions you can use. Just bang. Okay. So that's one style. All right, so let me move on to style number 2. Okay, so style number 2, again, if you want to contribute your suggestion for name, hashtag style number 2. This is it. Okay, I will zoom in, but in fact it's so small that I can just expand it. You can see the whole program now on my next slide. All right, so here's the whole program. And I'm gonna walk you through the lines because there's just 5 lines basically. So the first one, the first one over here just loads up the stop words. The second one opens the input file and loads up the words by eliminating, it's doing a lot of things. It's checking for for alphanumeric characters. It's checking whether there are stop words or not and eliminating them. So it's doing like at least 3 things in here in this one line of code. and you end up with a list of the words that you are interested in counting, okay? The next one is that you take those words, and there are many repeated words. So now we want to find out the unique words, right? We want to reduce and just find out the unique words. So that's this other thing that we're doing here. We have a set of the words, and the set in Python eliminates the duplicates. Now there's this line over here. This line is kind of funny. This line sorts the unique words by the number of occurrences in the original word list. Okay, so I'm giving it a comparer function, a lambda function, which is a comparer. And if you look careful about what's going on here, the comparer is actually live comparing. It's counting every time that you need a comparison. It's counting the words from the word list. Okay? And then you print them out. Now, it's 5 lines of code. Okay? It's great. If you try to run this, it takes about 5 minutes. Okay? And the problem is this thing here. You basically, every time that you want to find out how, the occurrence of the word Elizabeth, you go back to the original list of the words and you count the word Elizabeth. So for all the comparisons that you need to do for sorting, you're counting. Okay, so this takes forever. It's very, very bad in terms of performance. It's very good because it's really, really short. It's very bad for runtime performance. So, but there's another style on you, right? What are the characteristics of this style? Well, in this particular case, you also don't do abstractions. You don't have named abstractions. The goal here is to do it in as few lines of code as possible, right? And in order to achieve that, then you forego the abstractions, because abstractions add lines of code. You have to have definitions and stuff. And the other thing that you do is you try to use as much as possible all the advanced libraries that you can possibly find that do stuff for you. In fact, if there was already a library in Python that would do term frequency, that's what we would do. And you'd have 1 line of code, right? So you see people writing code like this, right? It's very short program, but each of the lines has a huge semantic load. And it's not necessarily easy to understand what's going on in there. Even though there's only 5 lines of code, some of those lines are really complicated to understand. They're trying to do a lot of things. So I'm calling it code golf. I don't know if you know what code golfs are. Who here knows what code golfs are? Okay, many people don't know. So there's a whole culture out there on the internet in development world that has this challenge called code golfs, that you try to solve these computational tasks in as few lines of code as possible. Look it up, Google code golf. You'll see, there's all sorts of, it has a culture out there that and to some extent that culture influences a lot of what's going on in software development, that people have on the back of their minds this idea that fewer lines of code is better, right? It depends. Sometimes it's not better. Or another way that we could call it try hard, maybe. You see this on people who are fresh out of undergrads and they were very good, and those people who got like A's and A pluses and they're really good and they know how to use all the advanced libraries and all the advanced features of the language, and they come up to you with this tiny little program that's really tiny but nobody else understands in the team. So there's style number 2. If you think that there's other names, let me know. Style number 3. Okay, so this is about a page and a half of code. And I'm going to zoom in here and tell you how this code is designed over here. So there's some global variables over here. Data, the word frequency, the words and the frequencies. And then there's a bunch of procedures, basically. Read the file, filter, normalize, scan, remove stop words, frequency, sort, okay? And then here's the main function. And the main function consists of just calling those procedures. Read the file, filter, normalize, scan, remove stop words, frequencies, sort, and then you print them out, okay? I'm sure that everybody here has written programs in this style, yeah? Yeah, this is a very, very recurrent style, very easy. What are the main characteristics of this style? Well, here's how you have to, here's the constraints that you need to apply if you want to produce programs in this style. You divide your problem in procedures, okay? What are these procedures? Procedures are abstractions that they may take input, they don't necessarily return any output, and certainly there's absolutely no requirement that they return output that's relevant for whatever they are doing. They may return maybe error codes or something like that, okay? So they are just procedures, little packets of instructions. There is usually some shared state that these procedures operate on, and basically the way that you compose the larger problem is by decomposing it in these smaller procedures and then just calling those procedures, basically giving these commands, right, one by one. So think about what we would call this style. I'm calling it cookbook style. Right, this is the kinds of expressions that you see in cookbook recipes. Mix the eggs with the butter, leave them on the side, mix the chocolate with the flour, and then that's exactly it's very natural for people, I think, to think about these cookbooks. Okay, here's another one. This one, I'm going to zoom in. It's about a page and a half too, and it's really, really similar to the one that I just presented. There's a few differences, and the details actually make quite a dramatic effect on the end result. But here's what it is. So you also divide the problem into smaller chunks, right? But each of these chunks now takes input and returns output. That's your constraint, okay? Each of these chunks is a function from inputs to outputs. And now what you do, so here are the functions, and in fact the functions, the division that I did is exactly the same as the one that I showed you before. But the way that you compose your problem, here it is, this line over here, the word frequencies, and I'm sorry, I had to rename the functions here, otherwise it wouldn't fit in one line, okay? But basically the way that you produce your big problem is by composing these smaller functions, calling them one after the other. So the output of one is the input to the next, and so on. Okay? So that's another style. Okay? Think about how to call this style. Here are the constraints. So what are the constraints? So what we really think, if you want to produce programs in this style, you have to decompose the problem in terms of functions. And when I mean functions, I really mean functions as you learned it in algebra, okay? As you learned it in mathematics. They are relations from inputs to outputs, okay? They're not procedures, they are mathematical functions. And in fact, if I'm really strict here about enforcing my constraints, they are so much relations from inputs to outputs that they can have no effect in the world, okay? You cannot have effects in there. Printing things on the screen, affecting file systems that should not be in these functions, okay? They are relations. That's your constraint. There's no shared state, and the way that you compose or produce the bigger problem is by doing mathematical function composition, F after G, just like we had learned in mathematics, okay? That's one style. It's constraints that you have to write it under. So think about what you would call this style. I call it the candy factory style, right? Candy factories, you have these little boxes that do one thing only and produce, do a coating on the candy and take the candy to the next box that does something else, and that's the candy factory style. Okay, style number 5. Here we go. Page and a half. This one, some of you might recognize, some of you might not recognize. This one has been popularized recently. Again, there's a bunch of little functions. The way that you do this, there's a bunch of functions here. Read file, they're essentially the same as the ones that I showed you before. Normalize, scan, remove, etc. But But now there's something special about these functions. There's one additional constraint, okay? And the constraint is that every one of these functions, if you notice, takes an additional parameter that's a function, okay? And the way that you're supposed to use this function is, at the very end, as you were about to return the value, you actually send that value to the function that you received as an input. And that's what you return, okay? You may think, what? Why would anyone do this ever, right? Why don't you just return the value that you were just about to return? If that would be the case, then you would end up with a candy factory style. This is a different style. There's an additional constraint. This is it. You have one constraint additional. That's you have this function that you get as a parameter. And what you do with it is that at the very end, the value that would be returning goes as an input to the function that you got. Okay? And so, here's the main code. You just call the first function, read file, with the argument. And then you give it the next function, which is the filter chars. Okay? So you're chaining functions by giving them as arguments to the function that you're calling. You probably have seen this, right? JavaScript does this all the time, right? It has been popularized. But this style is actually thank God, is one style that actually is called style. It has a style. But I'm not going to tell the technical name because otherwise some people here would just shoot me. So I'm not going to call it that name. So here's the constraints. The functions take this one additional parameter, f, that is called at the end, and given that function is given what would normally be the return value plus the next function. So you just chain functions like that. Okay, so think about how you was going to call this style. I'm going to call it kick your teammate. Basically, you're not just kicking the ball. You're kicking the ball and your teammate to catch the ball, right? That's what's going on in here. Or another way, if you are a little more inclined to feminine affairs like me, you call it the crochet style. You go and get the next function from, there's this thread that you always go and get the next function from, right? You probably don't know what I'm talking about. But anyway, so this image comes to me, crochet style, when I see this one. Some of you might know what the technical term appropriate to this one is, but I'm not going to use it. Okay, style number 6. Okay, so this one is actually quite different. This one is about 2 pages of code. And let me zoom in, and what's going on in here now is something completely different. Okay? So now I'm thinking of the problem as these classes of things. Okay? So there's a thing called the data storage manager that very obviously by the name takes care of the input. That's the only thing that deals with the input is this data storage manager. And then there's another one that's a stop word manager, and as the name says, that's the thing that takes care of stop words. And there's another one that's called the word frequency manager, that takes care of everything that's related to calculating word frequencies, right? So there's these managers and controllers and things in here. And so the way that you start the program here is you create one of these, the word frequency controller, sort of the main thing that starts the program, and you call, the procedure run on it, and you let it run. The code, the run does the right thing here, the right chain of reactions here. Now, everybody recognizes this, right? Actually, I have something else here just to illustrate another point of this style, is that all of these things actually reuse code that has been defined in this other type of thing, this TF exercise that's here, just completely irrelevant, just to illustrate the mechanism of this style, that you can reuse procedures that have been defined in other things. Okay, so we all know the technical term of this style, right? But I'm not going to say it. So what are the main characteristics here? Main characteristics, well, you design the problem, you think about the problem in terms of things. There's things everywhere, okay? And what are these things? They are capsules. They're capsules of data and procedures. right? The data is never accessed directly. It's only accessed through these procedures, okay? It's these things that define what procedures are they exposed to the outside. And moreover, these capsules can say, I do the same thing as that one, and more, okay? So think about how to call this style. I call it the Kingdom of Nouns style. And this is a reference for a really fun essay out there on the internet. Look it up, Kingdom of Nouns. I recommend. Very funny. So this is what you end up, programs that are written in these constraints end up with nouns being very important things in your programs, right? You end up with managers and controllers and adapters and all sorts of things, because those are the way that you think about the problem is in terms of these things. You model the problem in terms of things, and the things expose procedures. Okay, so here's another one. This one is a variation of the Kingdom of Nouns, but with one additional constraint. Let me show you what that is. So what's going on in here? Oh, no, I'm sorry. I actually removed that one. Okay, so this one is actually completely different. I'm glad I removed that one, because for a talk, it didn't add much value. This one's actually completely different, okay? This one, you think about the problem in a completely different way. So here's what's going on in here. Here's the main method over here. What you're going to think here is, wait a minute, I have a big file, right? And it could be really, really big. So I could potentially do things in parallel to speed up, right? I'm going to split the data, the file that I get, into chunks. And now I'm going to give each of these chunks into a worker that does exactly the same thing. They're just doing it in parallel. And then at the end, when these workers stop, I just merge everything, okay? And I produce the word frequencies. But in the meantime, I parallelized my task. So there's some gains in here, all right? So here's what's going on. There's a function that is called split words that takes exactly one chunk of input and splits the word, basically tries to identify the words, okay? And then you get these splits that very important, you apply a map function. Who here has applied a map or equivalent function in your programs? Okay, so map is a function that you give it a function as input and a list of data, and you apply that function many times, in parallel to that list, to each one of these chunks that you get it here. Pardon. And then what you do with those chunks, with those splits, you give it to another function, count words, that's going to reduce all of those things that you got, okay? And then you print it at the end. So here's the split words, and it's a little complicated. You actually need to look it over and think a little bit. If anybody has done this kind of style, anybody has done this kind of style? Yeah? Okay. This style is actually very simple, but it's the details that make it a little different, okay? There's like, a person who is trying always to optimize things goes into this map step and think, oh my God, I could do it so much better. But then you start thinking, oh, what's really going on is I'm making the problem very, very simple. So that's for the reduced step that comes next, okay? So here's the reduced step over here. So what are the constraints? Well, the constraints is that you divide the input into chunks, and you have these two abstractions. You apply a function in parallel, okay? And then you take those partial results and you reduce them somehow in a coherent manner, okay? So how would you call this style? I call it inverse multiplexer, okay? Inverse multiplexing, if you know electronics, is a concept that has been around for a few decades, okay? And there's nothing new. As I said, these concepts exist all over the place, okay? In electronics, as much as in programming, this has been around for a while. In fact, the MapReduce concept, oops, did I just say that? Has been around since the 60s, okay? It has been first introduced in Lisp a long time ago. Now it has been popularized with the Hadoop. And in fact, there's a variation of what I just showed you. I'm glad you didn't have time to look carefully at the implementation of these functions, because many of you would say, oh, this is not how Hadoop does it, and you would be right. So there's a variation that you need to introduce, another constraint that you need to introduce if you want to produce the Hadoop style. Okay, so style number 8. Okay, style number 8 is also very different. It's a completely different way of thinking about the problem. Different from everything that I showed you before. So the way that you think about this problem in this style is to think, okay, so I have data, right? I have an input data. So what I'm going to do is I'm actually going to store this data in tables, okay? I'm going to parse the data and store it in tables. And then what I really want to do, I want to count the words, yes, but I may want to count other things. I may want to get more knowledge out of this data, not just the word frequencies, okay? And I want to do it in a way that is very easy for me to state these specifications and get knowledge out of the data. Okay, so what is going on in here is that first I'm creating a SQLite schema. I'm creating the schema. I'll show you what it is. Let me show you what it is. Basically, it's these 3 tables: the documents table, the words table, and the characters table, because I might want to count the characters or do something with them. And so this is how I'm creating the schema. And then I'm loading the file into the database. Okay, and that is, at some point, here's what it is. I'm inserting the data, okay, over here, inserting everything, populating the database. And then, finally, once that is in place, then my program is really, really simple. I just declaratively say, well, select this from the words, group by something, order by something else. Super easy, right? I don't need to program as such. It's just these declarations. And then I print them out. Okay, so this is another way of doing term frequency. Another way of thinking about the problem, completely different. So what are the main characteristics? Well, the way that you think about the problem is that there are these, you think about your input data as entities with relations between them. And now, a constraint here is that you have to have a query engine. You have to be able to query these tables. And you do it by using this declarative query language. Very nice, that you don't write programs as such, you just declare what you want, and the query engine does it for you. Okay? Great. So think about how you would call this. I'm calling it Tabular. Okay, so I've gone through 8 of these. As I said, I'm a little obsessive compulsive when it comes to these exercises. And my goal here is to get 33. And I have about 23 at the moment in the GitHub repo. I'm writing a book about this. It's a book that is targeted for advanced programming students, but also for professionals who, for a reason or another, were not exposed to a lot of these things when they were in undergrad and they want to kind of crystallize. I mean, there's nothing new as such. There's only trying to make people aware that there's many ways to think about the problems. And in fact, some of those ways are very old. They were invented back in the 50s, for example. In fact, if you go to my GitHub repo, you'll see the first one is called Old Times. That is the style of writing programs that were used in 1951, basically. And there's all sorts of other styles. There's the REST style, too. Okay? If you heard about REST, yeah? Okay, so I have an example there that uses the REST style. So there's all sorts of different ways of thinking about the problem. And believe it or not, these things only accumulate. It doesn't go away. None of these ways of thinking goes away. They are good for some reason. Even the ones in 1951, okay? The styles that you wrote, of programs that you wrote in 1951, people are still writing it these days. And they are still good for something. When you have in a constraint that you have very small memory, small in the sense that it's smaller than the data that you need to process, and you need to compress things, and you really want to think about your memory, right? And you get away with lots of other redundant things. You put those redundant things in like comments or something, okay? Names of variables, put them in comments, instead of putting, there's all sorts of things. So the way of writing programs 1951 is still alive today. And same thing goes for objects and functions and continuations and relations and you name it. Lots of different things. And people will only come up with new ways of thinking about the problem. Okay, this doesn't end here. And if you thought that objects were dead and now functional programming is the cool thing, it's just really, it's not how the things work. You just accumulate and you have all these ways, styles that are good for some things and not good for other things. And it's up to, the project and you and your particular situation to decide what style you should be thinking for that particular case. What is it that you're trying to optimize? It's very important. So that's about it. And I welcome contributions, by the way. And 2 days after I put the code on GitHub, there were already people contributing like test cases, and the Candy Factory was the first one that people provided a shell script to do it. So I welcome implementations in other languages. I'm doing everything in Python, but you can do it in other languages too, because again, the styles are independent of the languages. So that's about it. Thank you very much. I'll take some questions.
How do you distinguish between style and patterns?
Good question. Okay, so we go into word wars again. So I think that essentially this trying to convey the same kinds of value, which is to convey experiences that people have accumulated over the years. And it's very hard to codify these experiences in mathematics or formal ways. So a really good way of expressing them is giving these examples, right? So the patterns book has these ways of thinking about the problem that people have seen in developing software that are good for specific situations. One thing that I'm trying to do here is a little bit lower level than that, if I may say so, which is to capture some ways of engineering the programs themselves. Okay, not just solving specific problems, but in engineering, in how do you engineer your code? How do you factor your code, basically? Okay, so that's sort of, it's very related, I would say. It's just different, if you want to say different patterns, if you want to use that word, and they're slightly lower level than the ones that are in the patterns book.
Okay. Thank you very much. I think time is up, and the rest of the comments and questions, you can get them on Twitter.
Okay, very good, and I'm
Thank you.
around.